In this video, we're going to go over momentum. In the first 2 minutes, we're going to go over what is momentum, what is the formula for it, and how to calculate it. In the next 3 to 4 minutes, we're going to go over what is the method, so a step-by-step instruction on how to solve momentum-related problems. And in the rest of the video, we're going to solve 2 practice problems that will demonstrate how this method works. So by the end of this, you should have a really good understanding of what is momentum and how to solve momentum conservation problems. Let's firstly start by examining the formula for momentum. Over here, we have that momentum P is equal to mass in kilograms times velocity in meters per second. So momentum is simply mass times velocity. Momentum conservation is similar to energy conservation statement. It says that the initial momentum of a given object is equal to the final momentum of the object. Momentum doesn't have a special unit, so since it's kilograms, mass, right, multiplied by velocity, meters per second, its units are simply kilograms per meter per second. So now that we have learned about momentum and momentum conservation, let's examine our method for solving these types of problems. Note that it will be very, very similar to energy conservation. So essentially, we're going to start by sketching the problem. So we're going to draw 2 separate diagrams to represent initial moments and final moments, right? Usually there's some kind of initial moment, then some kind of collision happens, and then what happens afterwards. For each initial and final moments, we'll label all the masses and all the velocities present, since that is what we use to calculate the momentums. We're going to calculate the total initial and total final momentum using our formula for momentum and set them equal to each other and solve for the unknown. So essentially, right, initial momentum is equal to final momentum, right? This initial momentum can consist of, let's say, 2 objects, then maybe they collide, they're colliding together. So the final momentum is like, let's say, some third object, right? And you basically plug everything in and solve, right? If this method doesn't make sense yet, it's all good, because in the next minute, right, we're going to go over our first example for momentum conservation. So in here, we have 2 blocks that are sliding on a frictionless surface. The first block has a mass of 2 kilograms and is moving to the right with a velocity of 4 meters per second. The second block with a mass of 3 kilograms is moving to the left with a velocity of 2 meters per second. Now, remember that the velocity is a vector, right? So in order to show that it has a different direction, I have to add a negative here. The blocks collide and stick together. So this right here represents the initial moment, right? Initially, the 2 blocks are moving like this. So following my method, right, I'm going to draw a diagram for the initial moment and now for the final. The final says that 2 blocks collide and stick together. So now they're essentially one object, right, with the total mass of 2 kilograms plus 3 kilograms, so 5 kilograms. And they're moving, let's say, I don't know in which direction, but let me just say it's to the right. It doesn't matter what your guess is, right? Just we don't know this velocity over here. So I made a diagram for my initial moment, for my final moment. For each object, I labeled masses and velocity. So that was the first step. Now, the second step, let me evaluate the total initial momentum, right? Which will consist with the momentum of this object, m1 times v1, and momentum of the second object, m2 v2. And let me calculate the final momentum, which is going to be, now we just have one object, so therefore there will be just one momentum. So it's going to be total mass, right, times this v unknown. So let me plug in all the numbers. So velocity is 4, so mass is 2 kilograms times 4 minus 3 kilograms times 2, right? Minus because this velocity is to the left. So that's the initial momentum, which is equal to 8 minus 6, so 2. And the final momentum is 5 kilograms times v. So let's set the conservation of momentum. Initial momentum, which is equal to 2, is equal to final momentum, which is equal to 5v, right? Therefore, if you divide both sides by 5 in order to solve for velocity, you get 0.4 meters per second as our final answer. So let's take a look at this problem again, right? Once more, the way we solve this is we firstly did a diagram where we indicated initial and final moments. For each of those moments, we found them, or we just basically wrote down each mass and each velocity. Then we calculated total initial momentum, total final momentum, and set them equal to each other to solve for the unknown. Now that this problem makes sense, let's take a look at the second problem in this video. Here we'll have a bullet with a mass of 0.02 kilograms that is fired at a velocity of 500 meters per second. So as you can imagine, right, this is going to be our initial situation, right? And towards two blocks, they are resting on a frictionless surface. So I could draw these blocks, right? But essentially, like, these two blocks are going to have, well, yeah, let me just draw them, right? And let me draw the final situation. So this is going to be my always, I recommend this setup for momentum problems, right? Like the initial and final. Okay, the first block has a mass of 1.5 kilograms. The bullet passes through the first block, which then moves with a velocity of 0.0 meters per second. So that's already a final moment, right? Once the bullet passed through the first block, right, that this block is moving with a velocity of 0.5 meters per second, I'm going to put that in the final box. So with every piece of information, you have to decide, are you going to put it in the initial or the final box? Then the bullet embeds itself in a second block with a mass of 2 kilograms. So here's the second block, right, that had a mass of 2 kilograms. But again, now since they're together, essentially the total mass, right, is going to be 2.02 kilograms, right? 2.02 kilograms. So, and after the bullet becomes embedded in the second block, they move together as a single unit. So we need to find the final velocity of this block and the bullet combination. Great. Okay, no problem. So let's take a look. It says that initially, right, these blocks are at rest, so their velocities are 0. So let's calculate once we draw a diagram, let's calculate our initial and final momentums. So initial momentum is going to be the following. It's going to be this bullet times, so the momentum of the bullet, so m times v. And the momentum out of the blocks are 0, right? Because they're not moving. So it's just going to be the momentum of the bullet, which is 0.02 times 500, right? Now, which is essentially going to be 1, right? 1 kilograms times meters per second. What about the final momentum? So final momentum, we have two objects that are moving. This first block through which the bullet passes and this combination of bullet and a block. So the first momentum, mv plus, let's call this m2v2. So 1.5 times 0.5 plus, right? So mass times velocity over here for the first block plus 2.02 times v2. Finally, let's set the initial momentum equal to final momentum. So initial momentum was 1 point, final momentum is this expression over here, 2.02, and solve for the unknown velocity, right? So it's just algebra that is left here in this problem. So I'm going to divide this by 2.02, plug this into a calculator, and find that second velocity is equal to 23.125 meters per second as my final answer. Great. So here's our, once again, notice the overall pattern of this problem. So again, setting up the initial moment and final moment, right? The setup of the problem is the most important part of any physics example. Then calculating total initial moment, total final moment, momentum, setting these two momentums equal to each other, and finding the final velocity. So in the next video, we're going to go over a very important type of momentum problems, which is called the elastic collision. So I would highly advise to watch the second video on elastic collisions because it will give you a deeper understanding of momentum and show you a different types of momentum related problems. Thank you guys for watching. Keep practicing and keep working on physics on your way to an A. Thank you.